Hi everyone. Today we will do class 10th chemistry chapter 1st chemical reaction and equation. First about myself, I am Bharat Bhushan Kugriti. I have done BSc honors chemistry from Delhi University. I have done MSc chemistry from Uttarakhand Open University. I have done master in mathematics from Sri Dev Suman University Uttarakhand. I have done MEd from HMD Gurwal University, also UGC NET education qualified. In this lecture, we will study about chemical reaction and its characteristic, chemical equation, balanced and unbalanced equation, how to balance an unbalanced equation, and third, type of chemical reaction with different example. First, chemical reaction. Chemical change or a chemical reaction are the changes in which one or more number of substances are formed. During a chemical reaction, an atom of one element do not change into those of another element. Only rearrangement of atom take place in a chemical reaction. Substances which take part in chemical reaction are called reactant. The new substance produced as a result of a chemical reaction are called product. Let's take example here. Magnesium plus oxygen gives you magnesium oxide. Here we can see arrow is here, it means it is going in a forward direction. We can see the substance which are present on the left hand side of arrow are known as reactant, and the substance which are present on the right hand side of arrow are known as product. Here we are having two reactant, one is magnesium, other is your oxygen. When magnesium combined with oxygen, it gives you magnesium oxide. Here the symbol for magnesium is Mg, oxygen O2, and magnesium oxide is MgO. This is a very important note here. Magnesium ribbon. This magnesium is known as magnesium ribbon. Burn in air. Air means it contains oxygen with a white dazzling flame. It is an observation that when magnesium burn in air, it gives a white dazzling flame, right, to form a white powder of magnesium oxide. Now, type of chemical reaction. Mainly there are 5 type of chemical reaction. First, evolution of gas. Second, formation of precipitate. Third, change in color. Fourth, change in temperature. Fifth, change in state. Now first is your evolution of gas. Some chemical reaction are characterized by the evolution of gas. Let's take an example here. We are having example of zinc plus sulfuric acid. When zinc is added to sulfuric acid, there is an evolution of gas. Here is an experiment shown. We have taken a zinc granule in a conical flask, right? We are having a conical flask and we put some zinc granule. We add sulfuric acid to it. We will see bubbles of hydrogen gas being formed around zinc granules. We will see bubbles of hydrogen gas form around zinc granules. If we test the conical with our hand, we will find that somewhat hot. So the change in temperature also occur in chemical reaction. This is a chemical reaction. You can see here zinc when react with sulfuric acid, that is H2SO4, gives you ZnSO4 plus H2 gas. Here the gas evolves is your H2, that is hydrogen gas. Next, formation of precipitate. Some chemical reaction are characterized by the formation of precipitate. A precipitate is a solid product which separate out from the solution during chemical reaction. Let's take an example again. We are having a potassium iodide. When react with lead nitrate, it is characterized by the formation of yellow PPT of lead iodide. Here then experiment is shown that we have taken in a test tube. A test tube is there. We are taking here lead nitrate. We have taken lead nitrate and we will add potassium iodide to here. This is solution of lead nitrate. We will add potassium iodide solution. After some time we will see that this solution become yellow in color and there is some solid part at the bottom of the test tube. This is known as your precipitate. This is the color is your yellow in color. Let's see the reaction. This is your formula for lead nitrate PbNO3 whole twice, right? We can write here PbNO3 whole twice plus potassium iodide gives you lead. Here should be an arrow, gives you lead iodide plus potassium nitrate, and this yellow color is of lead iodide. Now next is your change in temperature. Some chemical reaction are characterized by change in temperature. The chemical reaction between quicklime and water to form slaked lime characterized by change in temperature. Here we can see an example. In a beaker we take quicklime, that is calcium carbonate, right? And if we added water to it, then it changed into slaked lime, that is calcium hydroxide. And if you touch the beaker you will find it hot. It shows that there is change in temperature. Next, change in color also, right? Some chemical reaction are characterized by change in color. This can be explained with the help of an experiment. Again, here we are taking an citric acid and colored potassium permanganate, and the color is your purple color. Here it is in the experiment, it is given we have a test tube, right? In test tube we put some potassium permanganate solution, right? And the color is your purple color solution, the purple color solution. And to the solution we will add lemon juice. Lemon juice is your citric acid, right? Then and we will add drop by drop and shake the test tube. The purple color of potassium permanganate solution goes on fading and ultimately become colorless, right? This shows that in a chemical reaction the color changes from one color to another. Here in this case the purple color changes to colorless. Next, some chemical reaction are characterized by change in state. When wax is burned in the form of wax candle, then water and carbon dioxide is formed. Now wax is a liquid whereas carbon dioxide is a gas. This means that during a chemical combustion of wax, physical state of solid changes to liquid and gas. Now chemical equation. Representation of chemical reaction in term of symbol and formula of reactant and product is known as chemical equation. Here we can take an example. It is given zinc plus sulfuric acid gives you zinc sulfate plus hydrogen. This is your word form of equation. If we write this word form in the symbol and formula base, then it become a chemical equation. Here zinc is written as its symbol Zn, and sulfuric acid formula is H2SO4, zinc sulfate formula is ZnSO4, and hydrogen is your H2. Then the reaction becomes Zn plus H2SO4 gives you ZnSO4 plus H2. Here we can see that, right? Here we can see that on the left hand side of arrow these two are known as your reactant Zn and H2SO4, and on the right hand side of arrow these two are your product ZnSO4 plus H2 are your product. Now note, chemical equation is a shorthand method for representing a chemical reaction. Now balanced chemical equation. The balanced equation is in which number of atom of different element is same on both side of arrow is called balanced equation. Let's understand with the help of example. We are having same reaction, Zn plus H2SO4 gives you ZnSO4 plus H2. And reactant we are having Zn and H2SO4, and on the product side we are having ZnSO4 and H2. Let's see here number of zinc atom on the reactant side. Here you can see zinc is here, there is only one zinc on reactant side. Now on the product side zinc is here only, and there is only one atom of zinc. Now take the atom of hydrogen, number of hydrogen atom on left hand side there are two hydrogen we can see here, we will write here 2. And on the right hand side product side there are also two hydrogen, we will write 2. We can say that hydrogen are also balanced. Now third, number of sulfur atom on reactant side it is 1 here, and number of sulfur atom on product side it is 1 here. You can see sulfur atom are also balanced both side. Now number of oxygen atom on the reactant side it is 4, and on the product side again 4. Then both reactant and product having equal number of oxygen, then we say that oxygen are also balanced. Here we can say the number of reactant of each atom are equal to number of reactant of number of atom of product. Then we say this reaction is a balanced equation. Hence we say given equation is balanced as number of atom are equal on both side, or we can say they are same on the both side reactant and product. Now example number 2, let's take case of hydrogen plus water gives you hydrogen plus oxygen gives you water. Here you can see reactant side hydrogen how many 2, oxygen how many 2, and on the product side hydrogen it is 2 and oxygen it is 1. We can see hydrogen they are balanced but oxygen it is not balanced. Then this reaction is known as unbalanced reaction or equation, and also right unbalanced equation because oxygen has not same number of atom on both side. Now next is your how to balance this given equation. Let's again same equation H2 plus O2, this is H2O. Here we know that number of hydrogen atom are balanced but oxygen atom they are not balanced. We have to add here, this is 1, we have to make it 2, and only possible here is if we add 2 in front of this water, we have to add 2 here. Then because of it the oxygen become 2 and hydrogen become 4. So we can see here on product side we will multiply water by 2. Here you can see on the product side after multiplying water by 2 we get the reaction become H2 plus O2 gives you twice H2O. Remember here 2H2O. This 2 belong to hydrogen also, this 2 belong to oxygen also. Because of adding of these two, the number of hydrogen get changed. Earlier there were only 2 hydrogen. Now because of this 2, there are 2 to the 4 hydrogen and oxygen become 2. Now you can see here on the reactant side hydrogen remains same, it is 2, but on the product side the hydrogen are 4. On the reactant side oxygen become 2 and on the product side oxygen also become 2 now. But again this reaction is unbalanced here, hydrogen is not balanced. We have to now balance your hydrogen. In order to balance hydrogen we have to multiply by 2 on the reactant side, right? We have to balance hydrogen and we have to put 2 in front of hydrogen. Here you can see we will put here, now it become hydrogen become 2 to the 4. On the right hand side also it become 4, and on the left hand side you can see oxygen are 2 and here also oxygen are 2. Now number of hydrogen are equal, number of oxygen are equal, then this chemical reaction become equal. Then at last the final reaction will become twice H2 plus O2 gives you twice H2O. Now next example number 3rd, again a reaction calcium hydroxide plus O2 gives you calcium carbonate plus water. Let's balance this equation whether it is a balanced or unbalanced equation. Number of calcium atom you can see here, calcium it is here only 1 and on the product side calcium it is only 1. Calcium is balanced. Now number of hydrogen atom on the reactant side hydrogen it is here, you can see it is inside bracket and 2 is here. This 2 belong to oxygen also, 2 belong to hydrogen also. So hydrogen it is 2 here and on the product side again hydrogen it is 2 here. On the reactant side carbon, number of carbon is here, it is 1 carbon here, and on the product side carbon is here, it is 1 carbon here, you can see C. Now oxygen you can see here 2 oxygen here and 2 oxygen here, 2 plus 2 4 oxygen, and on the product side you can see 3 oxygen here and 1 oxygen here, 3 plus 1 4. Now you can see oxygen also get, oxygen number are same, then oxygen is also balanced. Hence we say that given equation is balanced has it has same number of atom on both side. Now next is your type of chemical reaction. There are mainly 6 type of chemical reaction. First, combination reaction. second decomposition reaction, third displacement reaction, fourth double displacement reaction, fifth redox reaction, and in redox reaction we will do oxidation and reduction reaction, and last we will do exothermic and endothermic reaction. Now first, your combination reaction. As the name suggests, it is combination, means combining of two more substances. Here let's see the definition. The reaction in which two or more substances combine to form a new substance is called combination reaction. For example, we can say magnesium plus oxygen. It will give you magnesium oxide. Here there are two substances, one magnesium, one oxygen. They combine together and they form a new substance known as magnesium oxide. Similarly, most common hydrogen plus oxygen, when combined together it gives you water. And third, iron plus sulfur gives you iron sulfide. Now second is your decomposition reaction. The reaction in which single compound break up into two or more simpler substances are called decomposition reaction. Here the meaning of this decomposition is to break into simpler part, smaller part. Now there are different type of decomposition reaction. First, electrolysis decomposition, second thermal decomposition, then third photochemical decomposition. First we will do electrolysis decomposition. The decomposition of a substance is because of passing electric current through it is known as electrolysis decomposition. We can take the example here. We are having water. We can break water by passing electricity to it, right? And it will break into two parts, that is hydrogen and oxygen. Similarly, we can also break aluminium oxide into aluminium and oxygen. The condition is only that we have to pass electricity. And third, NaCl can also break into Na plus Cl gas only by passing electricity to it. Now next is your thermal decomposition. As we know, thermal decomposition of a substance is because of heating of a substance. The definition is here: the decomposition of a substance on heating, and this decomposition occur because of heating. Here example are, we can say lead nitrate. If you heat lead nitrate, the sign of heating is your triangle sign. If you heat lead nitrate, it will give you lead oxide plus nitrogen dioxide and oxygen gas. Second example is calcium carbonate. When you heat calcium carbonate, it will give you calcium oxide and a gas always is carbon dioxide, which turn lime water milky. And third, potassium chloride. When it is heated, it give you potassium chloride plus oxygen. Now photochemical decomposition. Here we can see photochemical. That because of this name only we can say that photo means light and the decomposition is because of light. It is known as photochemical decomposition. See the definition. The decomposition of a substance by absorbing light energy is called photochemical decomposition. Right? Here example we can say AgCl. It is silver chloride. When a sunlight is provided, we can say here sunlight, right? It's changed into silver plus chlorine, and the color of silver is grayish white. We can see the color of silver is grayish white, and the chlorine gas evolved with yellowish green. Now next example we can take silver bromide, pale yellow color. Again, in the presence of sunlight, right, it changes into silver, which is grayish white color, and another compound element form, it is bromine, that is red brown. Now displacement reaction. See the definition here, that chemical reaction in which more reactive element displaces less reactive element from a compound are known as displacement reaction. Before going to example, let's see what are the most reactive and least reactive elements. Here we can see on the right hand side, this box is given. This is your reactivity series table. Here you can see your in this box you can see your potassium is at the top, right, and it is most reactive, and gold is at the bottom, is your least reactive. As you move down the arrow, right, your reactivity order goes on decreasing. We can say potassium is more reactive than sodium, calcium, magnesium, right, and similarly we can say gold is least reactive element, right. Now let's take example. Here we can say that which is the element which is most reactive can displaces other element from its position. Now it is given in example. First example, Zn plus CuSO4 gives you ZnSO4 plus Cu. Here you can see Zn and Cu is here. So we can see Zn is more reactive than copper. Then Zn displaces copper from its place and combined with sulfate ion form Zn sulfate and give copper. Similarly, copper plus AgNO3. Here copper, we can see copper is here, it is here Ag. Ag is your second last, that is silver. Then copper is more reactive than silver, then copper displaces silver from its position and form copper nitrate plus silver. And last reaction it is given zinc plus HCl gives you ZnCl2 plus H2. You can see zinc is at the top and H as bottom. The zinc is more reactive than hydrogen, it displaces hydrogen from its position and forms salt ZnCl2 and gas produces hydrogen gas. Now double displacement reaction, the chemical reaction in which compound react to form two different compound by mutual exchange of ion. It is said by mutual exchange of ion are called double displacement reaction. These reactions take place in solution, right. Mainly there are two type of chemical reaction which show double displacement reaction are precipitation reaction and neutralization reaction. The general reaction for double displacement reaction is A plus B and B negative combined with C plus and D negative. Here this A plus combined with D negative form A plus and D negative, whereas this C plus combined with B negative form C plus and B negative. Now neutralization reaction. In this type of reaction, an acid react with base to form salt and water by exchange of ion. You can see this is your base, NaOH is base, hydrochloric acid your acid, gives you salt NaCl and gives you water, right. Here you can see here Na is positive combined with negative of hydrochloric acid, that Cl is negative combined with negative part Cl form NaCl. Other we can say H is in hydrochloric acid, hydrogen is positive combined with OH and it form HOH. This HOH means water, that is H2O. Similarly in second part, CaOH plus H2SO4 gives you CaSO4 plus H2O. In this here Ca combined with sulfate form calcium sulfate, and whereas this hydrogen combined with OH form H2O. Now another example of double displacement reaction is precipitation reaction. In this reaction, aqueous solution of two salts are mixed, whereby some salt precipitate due to mutual exchange of ion between two salts. For example, let's take AgNO3 plus NaCl gives you AgCl plus NaNO3. We say that this Ag is positive combined with Cl, that is negative, from AgCl. There is mutual exchange of ion plus combined with negative, Ag positive, Cl negative, combined from AgCl. And similarly Na is positive and NO3 is negative, from NaNO3. These are mutual sharing. In mutual sharing of these ions, at the bottom of test tube some solid part या paste is collected at the bottom. This is known as your precipitate and we said by PPT. In this case, in this given reaction, right, here AgCl is formed and that, right, that is your PPT, and PPT is denoted by with an help of arrow. Another example, lead nitrate. The formula for lead nitrate, please correct it. It is PbNO3. That is whole twice. Lead nitrate, when react with potassium iodide, it gives you potassium nitrate plus PbI2, that is lead iodide, right? And here lead, you can see here potassium nitrate, it is given. Now exothermic reaction and endothermic reaction. On the basis of energy changes during a chemical reaction, they can be classified as exothermic reaction, or reaction in which heat is produced. You can see heat is produced, that is carbon plus oxygen gives you carbon dioxide. It means when you are having a simple paper, you take a paper, you burn it, when you burn it, you will see there is a flame also, and with the flame there is some heat also. So this is known as exothermic reaction. Now next, endothermic reaction, a chemical reaction in which heat is absorbed, is known as endothermic reaction. We can take the example here, calcium carbonate, right? We are having calcium carbonate, when we give heat, it give you calcium oxide plus carbon dioxide. Next example, we can take lead nitrate. Again, when heated, it give you, when we heated, it give you lead oxide plus nitrogen dioxide plus oxygen. And third example, we can also give one of the most important example or known example, it is your photosynthesis. We know photosynthesis, it is the process by which green plant make their own food in the presence of sunlight, right? When the plant gets sunlight, then only, then it means it is an endothermic reaction. Now redox reaction, chemical reaction which shows both oxidation and reduction reaction is called redox reaction. First, oxidation, reaction that involve gain of oxygen and loss of hydrogen is known as oxidation. Now reduction, reaction that shows loss of oxygen and gain of hydrogen is known as reduction. Both oxidation and reduction take place simultaneously, hence are called redox reaction. Let's take example. Here you can see an example given Z. Here we can see that this ZNO changes to Zn, and it is removal of oxygen, and by the definition, removal of oxygen is known as reduction, and ZNO goes to reduction to Zn, and it itself behave as oxidizing agent. In other case, we say carbon changes to your carbon monoxide, here oxygen is added, we can say that carbon goes to oxidation, as addition of oxygen is known as oxidation, and it itself behave as a reducing agent. Now one which behave as a oxidizing agent, it itself reduces itself, and one which behave as a reducing agent, it itself oxidizes. Let's see here, ZNO is an oxidizing agent and reduces to zinc, shows reduction, and carbon is a reducing agent and oxidized to carbon monoxide, shows oxidation. Second example, here you can see copper oxide changes to copper, right? Here we can see oxygen is removed, then it goes reduction, whereas in second, hydrogen changes to water, oxygen is added, it goes oxidation. And we know the substance which goes oxidation is known as your reducing agent, and the substance which go reduction is known as your oxidizing agent. It means if copper oxide is your oxidizing agent, then it itself reduces to copper. And we can also say if hydrogen is your reducing agent, then it itself oxidizes to water. Here it is written copper oxide is your oxidizing agent and reduced to Cu, shows reduction, and hydrogen is a reducing agent and oxidized to water, shows oxidation. Now next is your effect of oxidation in our everyday life. Mainly there are two most common effect of oxidation we observe in our daily life. First is your corrosion of metal, second is your rancidity of food. Now, corrosion of metal. The process of slow conversion of metal into their undesirable compound due to their reaction with oxygen, water, acid, gas, etc. present in the atmosphere is called corrosion. And the best example of corrosion is your rusting. Right? Iron, when react with oxygen and moisture means water, form red substance called rust. Let's take example. Iron means Fe plus oxygen give plus water. Here the X represent number of water molecules, form Fe2O3 dot XH2O. It is your hydrated iron oxide. That is the formula for rust. It is a very important reaction for exam point of view. Very important reaction. Now, rancidity. The taste of a food material containing fat and oil changes when they are left exposed to air for a long time. This is called rancidity. It is caused due to oxidation of fat and oil present in food material. It means when you keep your oily food for some time, right, it get a smell, right. This is known as your rancidity. This is because of oxidation. This is because of oxidation of fat and oil present in food. It can be prevented by using various methods, such as by adding antioxidant to the food material, right. We can add antioxidant which we can buy and we can put in that food. Second, by storing food in tight container, we can store that the oxygen supply is cut to the food and there will be no oxidation. Third, by flushing out air with nitrogen. Instead of normal air we can fill nitrogen gas, especially we can see in our Kurkure chips packet, the gas filled is your nitrogen. And third, keeping food in refrigerator. By keeping food in refrigerator there is less oxidation. Thank you class, thanks a lot. Hope you like it. Like and share it.